Here's a sentence you've probably read somewhere online. Everything causes cancer. Bacon causes cancer. Phones cause cancer. Plastic bottles cause cancer. Stress causes cancer. Sleeping with the lights on causes cancer. And here's the problem. Some of that is true. Some of it is wildly exaggerated, and some of it is just made up.
But it's all delivered with the exact same level of confidence, usually in a headline, usually with a stock photo of someone looking worried, usually with zero context about how much risk we're actually talking about.
That confusion isn't harmless. When everything is dangerous, people stop being able to tell what's actually worth worrying about. They ignore the risk factors that genuinely matter.
The ones backed by decades of data, while panicking about things that have never been shown to do anything to the human body. So, in this video, we're doing something different.
We're going to walk through what cancer actually is, in plain terms. The risk factors that the evidence actually supports, ranked by how much they matter.
The most common cancer myths and why they took hold, even though they don't hold up.
What actually moves the needle on your personal risk? The boring, unglamorous, well-proven stuff. And finally, how to think about risk in general, so that next time you see a scary headline, you have a framework panic response.
One thing before we start. This video is about population-level evidence, what increases or decreases risk across large groups of people over time. It is not medical advice, and it can't tell you anything about your specific situation. If you have personal concerns about your health or your family history, that conversation belongs with a doctor, not a YouTube video. What this video can do is make you a much harder person to mislead. Let's get into it.
Before we talk about causes, we need a SHES. It's a category of over 200 different diseases that share one core feature. Your body is made of roughly 30 trillion cells.
Each one of them is supposed to follow a life cycle. Grow, divide when needed, do its job, and eventually die and get replaced. That whole process is controlled by genes, tiny instruction sets inside each cell that tell it when to divide, when to stop, and when to self-destruct if something goes wrong. Cancer happens when a cell accumulates damage to those instructions, what we call mutations, and the damage specifically hits the genes that control growth and division. A cell that should stop dividing doesn't stop. A cell that should self-destruct because it's damaged doesn't self-destruct. It keeps copying itself, and its damaged descendants keep copying themselves, and over time you get a mass of cells that don't behave like normal tissue anymore. That's a tumor. If those cells gain the ability to break away and spread to other parts of the body, that's called metastasis, and it's a major reason why cancer becomes more dangerous and harder to treat the longer it goes undetected.
Here's the detail that matters most for this entire video: cancer and accumulation of damage over time. Most cancers in adults take years, often decades,
To become an actual tumor. This is why cancer risk rises so sharply with age. Older cells have simply had more time to accumulate damage, and the body's repair systems get less efficient as we age too. This single fact, that cancer is cumulative, not instant, is going to come up again and again as we go through both real risk factors and myths. A lot of the myths we'll bust later fail specifically because they imagine cancer as something that gets switched on by a single exposure, when in reality the body has to lose a long, slow battle of accumulated damage and failed repair before a tumor forms. It also explains something people find confusing: why a known carcinogen, a cancer-causing substance, doesn't give everyone who's exposed to a cancer. Exposure increases the odds of damage happening and accumulating. It is not a guarantee. Some people smoke their whole lives and never get lung cancer. Many more do. That's the nature of probability-based risk, not certainty-based risk, and it's worth holding on to that idea for the rest of this video. One more piece of vocabulary, because you'll hear it constantly in cancer research: relative risk versus absolute risk. If something doubles your risk of a rare cancer, that sounds terrifying, but doubling a very small number can still produce a very small number. We'll come back to this with real numbers later, because it's one of the most commonly weaponized statistics in health journalism. Before we list risk factors, it's worth understanding how we know what we know, because this is exactly where myths sneak in. The gold standard body for this is the International Agency for Research on Cancer, IARC, which is part of the World Health Organization. IARC convenes panels of independent scientists from around the world to review every available study on a substance or exposure, and they sort things into categories. Group 1, carcinogenic to humans, meaning the evidence is strong and consistent. Group 2A, probably carcinogenic. Group 2B, possibly carcinogenic. Group 3, not classifiable, meaning the evidence is too limited or inconsistent to say either way. And Group 4, probably not carcinogenic.
Here's the detail that gets instantly in headlines. That classification system tells you about the strength and consistency of the evidence that something can cause cancer under some level of exposure.
It does not tell you how potent the risk is or how much exposure it takes to matter. Processed meat and tobacco smoke are technically in the same hazard category, Group 1, because the evidence that they can cause cancer is equally strong and consistent. But that does not mean eating a hot dog is as dangerous as smoking a cigarette.
The dose, the frequency, and the magnitude of increased risk are completely different. This single point of confusion is responsible for an enormous share of the everything causes cancer headlines you've seen.
And we'll unpack it further when we get to processed meat specifically. The other thing to understand is how this evidence is gathered. Researchers generally use a combination of large population studies that track thousands or millions of people over years and look for patterns, laboratory studies on cells and animals that help establish a biological mechanism, and where ethical, controlled trials. No single study proves causation on its own. That's why scientific bodies wait for a consistent pattern across many independent studies from different research groups in different countries using different methods before they'll confidently say, this causes cancer. A single scary study covered breathlessly on social media is not the same thing as scientific consensus, and that distinction is going to matter a lot in the myth section.
Now let's get into what actually moves cancer risk, roughly ordered by the size of the effect and the strength of the evidence behind it. This is the single largest preventable cause of cancer worldwide.
Tobacco. Tobacco use is linked to cancers of the lung, mouth, throat, esophagus, pancreas, bladder, kidney, cervix, and several other sites. It's not just smoking either. Secondhand smoke exposure and smokeless tobacco both carry real, documented risk. Why is tobacco so much more dangerous than most other things on this list? Because cigarette smoke isn't one chemical, it's a delivery system for dozens of known carcinogens simultaneously, inhaled directly into the lungs at high frequency, often for decades. It's the combination of potency, route of exposure, and repetition that makes it uniquely dangerous. This is the clearest, most consistent, most heavily studied cancer risk factor that exists, and quitting, at any age, measurably reduces risk over time. The body does have some capacity to repair, it just needs the damage to stop accumulating. Next, alcohol. This one surprises people because alcohol doesn't carry the same cultural weight as tobacco as a cancer thing. But the evidence is strong and consistent. Alcohol is linked to cancers of the mouth, throat, esophagus, liver, breast, and colon. The mechanism is reasonably well understood. When your body breaks down alcohol, it produces a compound called acetaldehyde, which damages DNA directly, and alcohol also affects hormone levels in ways that are specifically relevant to breast cancer risk. The important nuance here is dose dependence. Risk increases with the amount and frequency of consumption, and there isn't a clean, universally agreed safe threshold the way there might be with some other exposures. Risk rises gradually rather than starting at some safe baseline and then jumping. That doesn't mean an occasional drink is equivalent to heavy daily drinking. The relative risk for light drinkers is much smaller than for heavy drinkers, but it does mean moderate drinking is risk-free. Isn't an accurate way to describe the evidence either.
This next one is one of the most underrated risk factors in public conversation, possibly because it's wrapped up in so much cultural noise about Midge. Strip that noise away and look at the biology.
Excess body fat, particularly visceral fat, increases the cancer risk for at least a dozen cancer types, including breast cancer in postmenopausal women, colorectal, endometrial, kidney, liver, and pancreatic cancer. The mechanisms are well established. Fat tissue isn't inert, it's metabolically active and produces excess estrogen, which is relevant to hormone-sensitive cancers. It also drives chronic, low-grade inflammation throughout the body, and inflammation is a known driver of the cellular damage that leads to cancer. And it's associated with insulin resistance, which affects cell growth signaling in ways that can promote tumor development. Physical activity, independent of weight, also appears to reduce risk for several cancer types, plausibly through effects on inflammation, hormone levels, and immune function, though the exact size of that independent effect is harder to isolate in research than weight itself. Now, diet. This is the category where myths run wildest. So, let's be precise about what's actually supported. Processed meat, meaning meat preserved by smoking, curing, salting, or adding chemical preservatives, like bacon, sausages, and deli meats, is classified by IARC as a Group 1 carcinogen specifically for colorectal cancer, based on a consistent body of evidence. Red meat more broadly is classified as Group 2A, probably carcinogenic, with somewhat less consistent evidence. Remember the earlier point about hazard classification versus magnitude. The increase in relative risk associated with regular processed meat consumption is real, but it is nowhere near the magnitude associated with heavy smoking. It's a moderate your intake finding, not a this is equivalent to a cigarette finding, despite how that comparison gets thrown around online. On the positive side, diets high in fiber, vegetables, fruits, and whole grains are consistently associated with lower colorectal cancer risk, plausibly through effects on gut bacteria, digestion speed, and inflammation. This is one of the more robust positive dietary findings in the field. What's not well supported? The idea that any specific superfood, juice cleanse, alkaline diet, or single ingredient meaningfully treats or prevents cancer on its own. Nutrition affects risk through overall patterns sustained over years, not through any single miracle ingredient. We'll return to several diet-related myths specifically in the next segment. Ultraviolet radiation from sunlight and from tanning beds is a well-established Group 1 carcinogen and the primary cause of skin cancers, including melanoma. The mechanism is direct. UV radiation damages DNA and skin cells, and cumulative sun exposure and sunburns over a lifetime increase risk. This is one of the most preventable cancer risk factors that exists. Sunscreen, protective clothing, and avoiding tanning beds genuinely reduce risk, and the evidence here is about as clean as cancer epidemiology gets.
This next one surprises a lot of people. HPV, human papillomavirus, causes virtually all cervical cancers and a significant share of certain throat and anal cancers.
And the HPV vaccine is one of the most effective cancer prevention tools that exists because it prevents the infection that causes the cancer in the first place. Hepatitis B and C infections are major drivers of liver cancer. H. pylori, a bacterium that infects the stomach, is linked to stomach cancer. This category matters because, unlike most risk factors on this list, several of these are directly preventable through vaccination or treatable through antiviral or antibiotic therapy, which makes them some of the highest leverage public health interventions in cancer prevention globally. There's also environmental and occupational exposures, things like asbestos, certain industrial chemicals, radon gas in homes, and air pollution. These tend to matter most for people with significant occupational or environmental exposure rather than the general population, but they're real, well-documented risk factors, particularly for lung cancer. Radon specifically is worth knowing about because it's invisible, odorless, and home testing kits are cheap and widely available. It's a genuinely underrated risk that gets far less attention than it deserves.
And finally, family history, which we'll come back to in more depth shortly. A smaller share are strongly linked to inherited genetic mutations. Like
BRCA1 and BRCA2 and breast and ovarian cancer. Now for the section a lot of you came for. We're going to go through the most persistent cancer myths, explain why they took hold, and explain what the actual evidence says. Myth 1. Sugar feeds cancer, so cutting out sugar starves it. This is one of the most widespread cancer myths, and it has just enough truth in it to be dangerous. Here's where it comes from. Cancer cells do consume more glucose than normal cells. This is actually the basis of a real medical imaging technique called a PET scan, which detects areas of high glucose uptake to locate tumors. But here's the leap that doesn't follow. All of your cells need glucose to function, including your brain, muscles, and every healthy organ. You cannot selectively starve tumor cells of sugar without starving the rest of your body first, because your body will simply convert other nutrients, protein and fat, into glucose if you don't eat carbohydrates directly. There's no diet that removes glucose access specifically from a tumor. Severely restricting sugar or carbohydrates doesn't starve cancer. It just risks malnutrition, especially in cancer patients who often already struggle to maintain weight during treatment. This is a real case where a popular myth can cause direct harm if a patient delays treatment or undereats based on it. Myth 2. Cell phones and Wi-Fi cause cancer. This myth has a real scientific hook. IRC did classify radiofrequency electromagnetic fields, the type emitted by cell phones, as Group 2B, possibly carcinogenic, back in 2011. That classification is frequently cited as if it settles the matter. It doesn't, and here's the key physics point that gets left out. Cell phones, Wi-Fi routers, and 5G towers emit non-ionizing radiation. Ionizing radiation, the type in X-rays, CT scans, and nuclear material, carries enough energy to directly break chemical bonds in DNA. Non-ionizing radiation, the type your phone uses, does not carry that kind of energy. It cannot break DNA bonds through that mechanism. Since that 2011 classification, the body of large-scale population studies tracking phone use and cancer rates over the following 15-plus years, and we've now had decades of essentially universal phone use to study, has not shown a corresponding rise in brain cancer rates that would be expected if there were a meaningful effect. Multiple major health and research bodies have since reviewed the accumulated evidence and have not found a consistent causal link. The honest scientific position right now is no established mechanism, no established population-level effect, but research attention continues, which is a very different statement than cell phones cause cancer, despite how that headline gets shared.
Myth 3. Nurses and deodorants cause breast cancer. This myth is based on compounds and antiperspirants get absorbed through skin,
Especially through underarm skin shaved or affected by nearby lymph nodes and accumulate near breast tissue. It's a plausible-sounding mechanism, which is part of why it spread, but plausible-sounding isn't the same as demonstrated. Large studies looking specifically at this question have not found a consistent association between antiperspirant or deodorant use and breast cancer risk. Major cancer research organizations that have reviewed this question consider the evidence insufficient to support the claim. Myth 4. Artificial sweeteners cause cancer. This one has a genuinely interesting history. Back in the 1970s, studies found that very high doses of saccharin caused bladder tumors in rats. That finding triggered warning labels for years. But follow-up research found the mechanism was specific to rat bladder physiology and didn't translate to humans, and decades of human population data on saccharin have not shown the same effect, which is why the warning labels were eventually removed. Aspartame got renewed attention in 2023, when IRC classified it as Group 2B, possibly carcinogenic, similar category to the cell phone classification, with similarly limited evidence. At the same time, the World Health Organization's separate risk assessment committee reviewed the same evidence and concluded there was no convincing reason to change the existing acceptable daily intake guidelines because the available evidence was considered inadequate to draw a firm conclusion. This is a good case study in why one classification of hazard exists in principle needs to be read alongside the actual strength of the evidence and the practical risk assessment from other expert bodies, not treated as a standalone verdict. Myth 5. Plastic water bottles and BPA cause cancer. BPA, a chemical used in some plastics, is an endocrine disruptor, meaning it can interfere with hormone signaling at sufficiently high exposure levels, and that's a legitimate area of ongoing research, particularly around reproductive and developmental effects. But the specific claim that drinking from plastic bottles causes cancer in humans is not well supported by current evidence at the exposure levels most people actually experience through normal bottle use. Regulatory bodies have tightened acceptable exposure limits over the years as research has evolved, which is exactly how science is supposed to work, but regulators are being more cautious about a chemical is different from this chemical has been shown to cause cancer in people who drink bottled water. Myth 6. Superfoods, juice cleanses, and alkaline diets prevent or cure cancer. The alkaline diet claim is built on the idea that cancer cells thrive in acidic environments, so eating alkaline foods can shift your body's pH and make it inhospitable to cancer. The biology doesn't support this. Your blood pH is tightly regulated by your lungs and kidneys within an extremely narrow range, regardless of what you eat. No food you consume meaningfully shifts your overall blood pH. If it did, that would be a medical emergency, not a wellness trend. Superfood is a marketing term, not a scientific category. Foods like blueberries, kale, or turmeric do contain beneficial compounds and can be part of a healthy diet pattern, but no single food, juice, or supplement has been shown to prevent or cure cancer on its own. The real, modest dietary findings we covered earlier, high fiber, lots of vegetables, less processed meat, sustained over years, get repackaged into much bigger, much less accurate claims about individual miracle foods. Myth 7. A biopsy or surgery causes cancer to spread by exposing it to air. This is a genuinely understandable fear because it sounds mechanically plausible. Cutting something open, exposing it to air, makes intuitive sense as releasing something. But cancer doesn't spread because it's exposed to air. It spreads through specific biological pathways, primarily the bloodstream and the lymphatic system, and that process is driven by the tumor's own biology, not oxygen exposure. Biopsies are designed with specific techniques precisely to minimize any disruption to the tumor, and they remain essential because an accurate diagnosis is what allows effective treatment to happen at all. Avoiding a biopsy out of fear of this myth delays diagnosis and treatment, which is a real harm, in exchange for protection against a risk that isn't actually how metastasis works. Myth 8. Power lines and microwaves cause cancer. Similar physics issue to the cell phone myth. Power lines emit extremely low-frequency electromagnetic fields, and microwaves use non-ionizing radiation specifically designed to heat water molecules in food, contained within a shielded appliance. Large studies on power line proximity have produced inconsistent, generally weak associations that haven't held up as a clear causal pattern across follow-up research, and there's no established mechanism by which a properly functioning microwave oven would cause cancer in the people using it. Myth 9.
Underwire bras restrict lymph flow and cause breast cancer. This claim has been specifically studied, including a large study designed to test exactly this question.
Myth 10, which isn't so much a myth as a dangerous oversimplification. If it's not in your family, you don't need to worry. The majority of cancers occur in people with no significant family history at all, driven by the accumulated lifestyle and environmental factors we covered earlier, plus ordinary chance accumulation of mutations over a lifetime. No family history is reassuring information, but it is not the same as no risk, and treating it that way is one of the more consequential misunderstandings in how people think about their own risk.
None of this is a guarantee. Remember, cancer risk is probabilistic, not certain, for everyone in both directions. People who do everything develop cancer, and people who don't can still avoid it. But shifting probability in your favor, repeated over a lifetime across millions of people, is exactly how public health works, and this kind of information can make. If you take away one thing from this video, I'd want it to be this: the slow accumulation of damage balanced against your body's equally real capacity to repair itself. Like and subscribe if you want more videos that take health information seriously without the panic, and let me know in the comments what myth surprised you most or what topic you want broken down like this next.